So far we have seen that the derivative of the natural log of x is 1 over x. And now we want to show that the derivative of the natural log of the absolute value of x is also 1 over x. Recall that by definition of absolute value, the ln of absolute value of x is the same as ln x as long as x is greater than 0. And then if the ln of absolute value of x is equal to the natural log of negative x, if x is less than 0. And we have already shown that the derivative of ln x is 1 over x, and now we also need to show that the derivative of ln of negative x is also 1 over x. And so this is negative x. And so we have to use the chain rule right here. And so the derivative of natural log of negative x will be 1 over negative x, and then times the derivative of the negative x. So this is 1 over negative x, and then times, and the derivative of negative x is just negative 1, and therefore we get 1 over x. And so now we have shown that the derivative of ln x is 1 over x, and the derivative of ln of negative x is also 1 over x. And therefore, we can say that the derivative of the ln of the absolute value of x is equal to 1 over x. And since the derivative of ln of the absolute value of x, which means that we do the antiderivative, and so this means that the antiderivative 1 over x will be the reverse, as it will be ln of the absolute value of x, and then plus a constant. So derivative ln of absolute value of x is 1 over x, and therefore the antiderivative of 1 over x must be ln of the absolute value of x. And now let's get a formula for something like this. Just an extension of 1 over x. So we have 8x, and then plus b. Okay, this will come up quite often, and so let's go ahead and work this out so we can use this formula later on. And so for this integral, what we want to do is use the substitution method, and so we'll let u be 8x plus b. And then we need the derivative of u, which is du dx. And so the derivative of 8x, the constant a times x is just a, and then the derivative b, constant b is 0, and so we get a. So we have the differential of u divided by differential of x is equal to a. And therefore, by definition of differentials, we have differential of u is equal to the constant a times the differential of x. And so now we're ready to make the substitution. So 8x plus b, we call this u. And then here we have dx. And so we need to write dx in terms of du. But here we have dx, but here we have a dx. And so what we need to do is go ahead and get rid of the a, so we can multiply both sides by 1 over a. And this will give us dx. And so dx is equal to 1 over a times du. And so in the place of dx, we can put 1 over a du. But the 1 over a is just a multiplication constant, and so we can put it in front of the integral sign. And then what's left is just 1 over u times du. We have seen that the antiderivative 1 over x is the natural log of the absolute value of x, and therefore the antiderivative of 1 over u would be just the natural log of u. So this would be 1 over a times the natural log of u, and plus c. And therefore this integral right here is going to equal to 1 over a, and then times u is 8x plus b, 8x plus b. And this works for minus 2, and so let's say instead of plus, if we have a plus and minus, then the result right here will be plus or minus. And so this type of expression, this type of integral, it will come up quite often, and so we can, every time it comes up, we can just use this formula right here, so we don't have to redo it over and over again. Here we want to find the indefinite integral of 1 over 7x plus 2. And so this type of integral, it has this form, 1 over 8x plus b, and so we can just use this formula we've just developed right here. And so this integral right here. And so a would be 7, and then b would be 2. And so this would be 1 over 7, and then times the natural log of the absolute value of 8x plus b, and so it would be 7x plus 2, and then plus the constant, and this is the answer.